Okay.
All right, good evening, class. Today we're going to talk about, oh, there you are. Today we're going to talk about inverse functions with sine, cosine, and tangent. We're going to learn how to graph them and what their domains and ranges are. So there's a line of light across my face. It's called a halo.
It's called a halo. It's because he's an angel. That's why. All right, guys, what's going on? So today we're talking about inverses. So you want to take a little notes. Inverse trig functions. That's what we're working on today. Inverse trig functions. There you go. ITF, baby. Inverse trig functions. All right, so why the inverses? Why is this necessary? Why is it important? Well, let's just take, for example, an equation like the sine of theta equals 1/2. Now, you guys remember when we start to solve for the variable in question, we need to isolate the variable, get it by itself. Well, if you'll look, I have sine of theta equals 1/2. How would we undo that sine from that theta to get theta by itself, Mr. Simmons?
Well, first you divide each side by s, then divide each side by I, and then divide each side by n.
And you would be wrong. That is not sine times theta. It is sine of theta. It's a function. So we need to undo a function by using its inverse. That's right. So we want to get theta by itself. So we'll do the inverse. So I don't know how familiar you guys are with inverse notation, but when you say sine to the -1, that's inverse notation. So sine of -1 of sine of theta. And in algebra, if we do it to the, wait a minute, we're in trig. Do we do algebra in trig, Mr. Simmons?
Yeah, I think so.
Yeah. If we do it to one side, we have to do it to
the other side.
Other side. Now that sign doesn't cancel out, this sign inverse doesn't cancel out that sign. It undoes the function. Kind of like the way square undoes square root.
Right.
Or square root undoes a square. It's the inverse operation. So I'm left now with theta equals the sine inverse of 1/2. That's sine to the -1. Superscript is
so this is
-1.
asking, let me get this straight, this is asking the angle whose sine is 1/2.
Yes.
Is that correct? Okay.
Yes. Now if we were to further answer this question, you guys know where sine is 1/2. Sine is 1/2 in two places.
Pi over 6.
Pi over 6.
And 5 pi over 6.
And 5 pi over 6, right? So that's two different places that sine is 1/2. But I think there could be a problem with that, Mr. Simmons. Why don't we talk about what the problem could be with this particular function? All right.
Having two solutions.
Having two solutions. If I were to draw this graph of y equals sine x. All right, let's see if I can get a couple of decent periods here. Well, that one looked good. That one didn't look so good. Now, I don't know how versed you guys are with inverses, but when you take the inverse of something, some things change, some things switch, right?
Yeah.
We'll come back to that. When you take the inverse of something, it reflects across this line y equal x.
That 45-degree angle.
That's right. So let's see if I can't get this drawn up there decently. We'll call this line right here the line y equals x. Now what happens is this line that's here, I'm going to maybe grab this line here, and oh, it's not going to let me. I was going to move it. Move the whole thing. That's okay. So what happens is we have a reflection, Mr. Simmons. This part here, whoops, this part here reflects, it's a mirrored reflection.
Okay.
And then this part here is a mirrored reflection above the line. So if I were to complete this and reflect,
okay,
I believe we run into a problem. What's the problem, Mr. Simmons? What's the problem with our inverse function?
Well, there's not anything wrong with the inverse part. The problem comes with the function part because it fails the vertical line test.
The vertical line
test. And if it does
test.
not pass the vertical line test, technically it's not a function.
It's not a function.
Yeah.
So I guess the question here is, how can I take y equals sine x, the original sine function, and maybe restrict it a bit to try to make sure that my inverse is a function? Well, let's take a few of the things off. Let's take y equals x off here for a second. All right. So let's restrict it. So
Okay.
I don't know if you guys are good with the horizontal line test, but it tells you if the inverse of a function is a function. So if I run the horizontal line test, I'm hitting it at that point, that point, that point, that point, all of these points, I'm failing. So what we need to do is restrict our domain, our input, if you will, of the original sine x to a couple of different points. Here, which we know is negative pi over 2, and here, which we know is pi over 2. And when we restrict that domain, that means the rest of this stuff goes away. So right now, look, remember I'm failing the horizontal line test, and if this were an inverse function, if we were to plot the inverse, we would fail the vertical line test. What that does is take part of my graph away. Again, guys, we're restricting the domain. So that's what's left of our sine function, just a little piece, a little
So we're
snippet, if you
restricting the
will.
domain, the angles from negative pi over 2 to positive pi over 2.
That's right. That's where the inverse is allowed to play.
But you'll note all of your possible sine values from -1 to +1 are represented in this restricted area.
That's right. -1 to +1 is in there. All right. So what does that mean for us? Well, it means that now when we're looking at the inverse of sine functions, we don't get to play where we normally used to play. Let's look at a picture here really quick, guys, if you will. And I'm going to try to get all technical and fancy, Mr. Simmons, just to try to make this thing look nice.
Ooh,
You like that, don't you?
circle.
All right, so when I do that, so we're restricting our domain. You guys remember on the unit circle, this is 0 pi, right? And if I rotate counterclockwise, that's pi over 2. And of course we can keep going. But if I rotate clockwise, this becomes negative pi over 2. So we only get to play on the unit circle with the inverse functions from negative pi over 2 to a positive pi over 2. So that would be in the 4th quadrant and the 1st quadrant. But you got to be careful. This isn't 3 pi over 2. Yes, it's in the same place on the unit circle, but remember 3 pi over 2 on the graph is way over here. So we don't get to play in the same place.
Excellent point.
Now, and this is something you got to remember too. Since we're sweeping from 0 over to negative pi over 2, this no longer is 7 pi over 4.
No.
It is
Negative pi over 4.
negative pi over 4. And this is still positive pi over 4 and positive pi over 6 and positive pi over 3. But I'm negative pi over 6, negative pi over 4, negative pi over 3. So that's what you got to remember when you're solving these equations using these principal values that we've got going on here. Well, cosine is probably similarly done.
I would imagine so.
So let's do a cosine function really quick, and let's look at that. So a cosine function, and of course, if you remember, we start cosine with a max,
Yep.
and we go down and come back up to a max, and then we go down and we come back up to a max, right? There's a couple of periods of cosine there. It's not very beautiful, but you guys get the picture. I guess I could make it a little nicer, a little cleaner here, but see if I can't come up there a little bit. All right. So remember, we said we can run the horizontal line test to determine if the inverse is a function. That is, if I were to flip everything across that line y equals x, it would do this. It would snake vertically, if you will.
Yep.
So let's run the horizontal line test.
Beep, 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 beep.
Oh my goodness. We're hitting 2 points, and that's no good. That means that the inverse is not going to be a function.
Correct.
So what we need to do is restrict the domain,
Again.
very similar to the way we did on sine, restricting the domain of the original sine.
We want to make sure our restricted domain has all the range values from -1 to +1 and all the points between them.
That's right. So if we go here and restrict the domain, we need restricted. Well, we can't go negative pi over 2 to pi over 2.
Like we
Because
did with
it's-
sine.
Yeah, if we do that, we still have a failure in our inverse. So this time we're going to restrict it a little differently. Remember, this is 0, Remember, this is positive pi. So when we restrict, we're going to restrict our cosine function, the original cosine function, to just this part of the graph that you see from 0 to pi. So now if we were to, I'm going to go back and grab this right here, and I'm going to take that baby with me over to the cosine one. Alright, and then I'm going to look at it. Remember though, we're not going from negative pi over 2 to pi over 2 like we did in sine. The inverse cosine function plays from 0 to pi
From 0 to pi?
In this
0 to pi.
direction. 0 to pi. So, inverse cosine 0 to pi, not negative pi over 2 to pi over 2 like sine, 0 to pi. Alright, so let's continue on here. Skip that one, come here. Alright, so I already had the tangent function drawn. Yes! That is one period of tangent. Pi, not 2 pi. So if we do this, I'm going to, I guess we'll leave this here just for saying. Now if we reflect everything across, now if you'll notice, there's no U shape or mound shape or whatever that would fail the vertical line test. But if I were to continue with another period, then I would hit 1, 2 of these, right? If I were to continue with another period and run that vertical line test, I hit here and I hit here. That's no good to me. So I've got to restrict the domain. I've got to restrict the domain to just this middle period right here. And when we do, and look at the inverse, the vertical asymptotes become my
horizontal
asymptotes. And then when we reflect it across, we get something that looks kind of like this. Now you can't use multiple periods, guys. You can only use that period in the middle, which we use here. So, interestingly enough, if I were to look on the unit circle, kind of like what I did earlier, let's see if I can't get a unit circle drawn up here. I get a unit circle, it's still able to play at negative pi over 2 to pi over 2. So there's my 0 pi, there's my positive pi over 2, there's my negative pi over 2, and I get to play in this area, negative pi over 2 to positive pi over 2. So let's kind of summarize here if we will. Here's the summary. Notice the inverse notation on sine x, cosine x, and tan x.
Yep.
The domain of sine x was the restricted, was the range of y equals sine x.
Which was -1 to +1.
Which was -1 to +1 inclusive. But you remember on the original y equals sine x, we restricted the domain to
negative pi over 2 to positive pi over 2.
Negative pi over 2 to positive pi over 2. And are they inclusive, Mr. Simmons?
Yes, they would have to be.
They would have to be. There we go. And then for cosine x, if you remember the range originally for sine x was -1 to, cosine x, -1 to 1. Well, in inverses, they swap. Domain becomes the range. So this is -1 to 1. And then, but now remember, we had to restrict the domain from 0
to
pi. And then for tan x, now let's just back up for tan x and look at the inverse for a second. Here's the inverse, right? So if we look at the inverse, you look at the range, this thing goes left forever and right forever. That's all real numbers.
Correct.
Well, remember on the original tan x, the range was all real numbers, negative infinity to positive infinity. So that's what becomes my domain now, negative infinity to positive infinity.
Is infinity defined as a value?
No, it's not, Mr.
Okay,
Simmons.
so let's put parentheses there.
Minus points for Mr. Mack. So parentheses here. Now, how do we define the range? Well, if you remember, just backing up one slide, it's negative pi over 2 to positive pi over 2.
But that's where our asymptotes were.
So I don't get to put a bracket?
No. Use a
Dang it! Use a parentheses. Okay, So this is the summary you're looking for. These are where the places I like to say that these inverse functions gets to play. When you're finding the values of these inverse functions, these are the places that they get to play. And they don't get to play anywhere else unless we have defined the restriction to a different domain other than what it is to make the inverse of function. That's going to come up in the next section. And in the next section, we may say on an interval from 0 to 2 pi. So we're going to open these up a little bit. But if I don't define it on anything else, and I say, find the inverse, find this value, these are the places I get to play. For the inverse sine, it's negative pi over 2 to pi over 2. For inverse cosine, 0 to pi. For inverse tangent, negative pi over 2 to pi over 2. Now there's one more word, vocabulary, I want to throw in here before we quit. The inverse of sine is also known as arc
sine.
There you go, arc sine. What about inverse cosine, Mr. Simmons?
Well, using, if our prefixes are uniform, I would say arc cosine.
Arc cosine and
arc tangent.
Arc tangent. So that's another way to say inverse. Arc works the same way. We're about to run out of time, but I want to show you one example before we quit. We just got bright in him, Mr. Simmons. All right, one example before we quit. If I wanted to know the inverse cosine of the square root of 2 over 2 positive, and I said, what is that value? Well, we know that arc cosine and inverse cosine only gets to play from 0 to pi.
0 to pi.
And cosine is my x value. So where is our x value square root of 2 over 2?
Well, we get square root of 2 over 2 at pi over 4 and 7 pi over 4. But we're restricted from 0 to pi. So we have to throw out that 7 pi over 4 and just keep the pi over 4.
Now you're seeing why we get to use those restricted domains. I didn't get to include 7 pi over 4 in my answer. Alright guys, that's where we're headed, doing a little bit of inverses on sine, cosine, and tangent. Watch this video, it'll be on Mr. Simmons and Schoology as well.
Yep.
Of course you won't know that, I just said that in the video, but you gotta watch the video to find out. Alright, good luck guys with inverses. We'll pick up where we left off.
Yeah,
See
we'll
ya.
see ya.
Bye.